Today, we want to keep talking about those big three trigonometric functions. They're going to be very important to us because the game that we want to play is solving triangles. Triangles have three sides and three angles. I've got the sum of the angles in any triangle is 180 degrees. That's all about the angles. That's fine if I've got two of the angles. And we've also got the Pythagorean theorem for right triangle, which is fine if we've got a right triangle and we know some sides, but we need something to connect the two. I need some crossover between the angles and the sides to help us figure out the rest. And that's where we introduce trig functions. So the big three trig functions that I asked you to remember from last time are sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. I left off the theta because we can be casual like that. Sine of theta is opposite over hypotenuse is how we should say it if we're going to be formal. But if we want to remember it, we just need to remember the sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. All right. So this is all relative to a named angle. This is all relative to the theta. So I've drawn a picture up here, and if theta is the angle down here on the bottom, then this vertical leg is the side opposite theta. That's the side opposite theta. And this leg that it is connected to, that theta is connected to, is the side adjacent to theta. The hypotenuse is always opposite the right angle. The hypotenuse is always in the same place. So it's the other two that we have to make the distinction. Notice that what is opposite this angle theta is adjacent to the other angle. In this case, I called it phi or phi. So I don't think we used this one, introduced this one last time, but this is phi. So this angle, this side is adjacent to angle phi, and what's adjacent to theta will be opposite angle phi or phi. So let's drop down here. We want to find sine theta, cosine theta, and tangent theta for these two triangles. So I've got this angle theta down here. I've got this side is, this leg is 3, this leg is 4. I don't have the hypotenuse, but secretly it's a right angle. We have a right triangle. We have the Pythagorean theorem we'll use. But what can we determine right now? What is 3 relative to this theta? What do we call this leg? Opposite, because if we stand here at theta, put our hands on the two sides that make theta, we are looking out at 3, so that's the opposite. This side is opposite the hypotenuse, or sorry, opposite the right angle, so it is the hypotenuse. And what does that leave 4 to be? Adjacent. So without any calculation, I have opposite and I have adjacent. Which trig function can we, which trig ratio can we write down right now? Tangent. Tangent is opposite over adjacent. So I could say that tangent of theta, I don't like using it. It's fine. It's fine. Right off the bat, I can say tangent of theta is 3/4. Later on, we're going to have to figure out how we can use this to figure out what the angle theta is. But for right now, tangent of theta is 3/4. For sine and cosine, we're going to need to know the hypotenuse. So how can we find the hypotenuse? What are we going to use? We'll use the Pythagorean theorem. The sum of the squares of the legs. So 3 squared plus 4 squared is equal to c squared. So 3 squared is 9, 4 squared is 16. That's 25 equals c squared. So how much is c? Now that we have the hypotenuse, we can write down sine and cosine. So what is sine of theta? Opposites over hypotenuse, which is 5, so 3/5. And what is cosine theta? 4/5. Once again, we're going to have to use some calculator magic to figure out what the angles are, but we'll go on our way. Any questions? How's everybody? Okay. Isn't trig easy? I'm going to remember you said that. On the other triangle, what is the 12 relative to the angle theta here? 12 is adjacent to the theta. And what is 13? Hypotenuse. So in this case, we don't know what the side opposite theta is, but we can write down one of our trig ratios right away. Which one involves adjacent and hypotenuse? Cosine. So we can say that cosine of theta is adjacent over hypotenuse. But now we're going to need to figure out the side opposite. We don't know the opposite yet. Fortunately for our heroes, we do have a right triangle, so that means Pythagorean theorem is in effect. I'm going to call adjacent A and the opposite B. And the hypotenuse is 13. So here we're going to do a little bit different operation to get at the side that we want. Before we just had to add those two up, but now we're looking for one of the legs. So B squared is 13 squared minus 12 squared. So 169 minus 144. What's 169 minus 44? 25. I didn't want to have to do too many square roots today, so it's always just going to be 5. So B is 5. Now that we have the opposites, we can figure out the other two trig ratios. So what is sine of theta in this case? And what's the missing one? Tangent. So tangent of theta is opposite over adjacent. Any questions? How's everybody okay? Good. So we're going to have to use our calculating machines to figure out angles from their trig ratios. We need calculators to find angles. We are going to learn some angles that we're just going to know the sine, cosine, and tangent of. But in general, unless it's those specific angles, we're going to need calculators to find the angle. We're going to have to do this in 2 different styles because calculators tend to come in 2 different styles. I'm going to call one TI-84 style and the other one, phone style. Some of you will have a TI-84 or a TI-83, if you like vintage calculators. If you have a TI-82, wow, I'm surprised that it still works. If you have a TI-85, that's like super vintage. That was like the original, the OG graphing calculator. It's funny because we refer to these as graphing calculators. They aren't very good as graphing calculators, but they're great at being just calculators. But if we want graphing, there are better places. I mean, you can actually see the individual pixels. It's like, well, this is a graphing calculator. I can see the pixels. How good can the graphics be? But anyway. So there's going to be two styles. There's going to be TI-84 style. This is where we're going to be typing things as we see it. And there's going to be phone style, which is a little bit old school. So let's do some calculations. So actually, let me just write down the way I think of these. TI-84 style, type it like you see it. TI-84 style, just type it like you see it. Phone style, the buttons don't work that way. You don't push the button. It applies the trig function to whatever's on the screen. So it's kind of backwards, but it also kind of makes sense. Lots of people report that it feels kind of backwards to do it this way because the button applies to whatever's on the display. That's how sine, cosine, and tangent tend to work on your phone application. It all depends on what happens when you press the sine button. So let's press the sine button. So we're just going to evaluate some stuff. And we're going to start with, let's say, sine of 37 degrees. Here are the things that we have to do. First of all, you have to remember that you are talking to a computer. For a TI-84, it is a very limited computer, but it is still nonetheless a computer. And computers are very dumb. They will do exactly what you tell them. They don't get any kind of nuance. They just do exactly what you tell them. If you ask them the right question in the wrong way, they will not know what you're talking about, but they will give you an answer. And it might not be the one that you're looking for. That makes sense? Computers don't understand like language. They just do what they're told. Which on one hand, that's great. On the other hand, oh gosh, it's annoying. So here are the things that you have to worry about. We're going to start with TI-84 style. Number one, I'm asking you for the sine of 37 degrees. So we got to make sure our calculator is in degree mode. So number one, get in degree mode. So for the TI-84, other calculators of this type will be similar, but for the TI-84, you're going to want to go into the mode button because you want degree mode. And notice that there's that blinking normal. If you scroll down, notice that radian is highlighted, but I want degree mode. So I'm going to want to go over to degree and hit enter. And now degree is highlighted. My calculator is in degree mode. Now that we got the right mode, we can quit. So the quit is in blue. So that's the second function of the button. So press second and then quit, and you're back to the home screen. TI-84 is type it like you see it. So I'm just going to press the sign button and then 37, and I'm going to close parentheses because I'm trying to build good habits with my parentheses. And then hit enter. There it is, 0.6018. So in TI-84 style, you type it like you see it. So on TI-84, you're just going to type sign 37. You're going to close parentheses because you're going to build good habits with your parentheses. And then you hit enter. 0.6018. I didn't specify where to round it, so I just picked 4. I was going to round to the nearest thousandth, but then I wrote the 10,000th, and I didn't want to erase. So let's switch over to phone calculator, which is the one that most of us will be using most of the time. So depending on I have an iPhone, but most calculators are phone calculators are similar. So this is where I get an embarrassing text message. Hey, the dog barked again. Here's a picture of it. What do you think is going on? Notice that we don't see sine, cosine, and tangent because normally we don't need them. But if we switch to landscape, then our other functions appear. So there's our sine, cosine, and tangent. This works differently. I don't want to press the sign button because on this style of calculator, pressing the sign button just takes the sign of whatever's on the display. And sine of 0 is 0, and it looks like nothing happened. So what we have to do is enter the angle first, 37, and then press sine. So phone style, angle, then sine. Notice that I didn't have to press equals. I didn't have to tell the calculator to stop. That just says take the sign of whatever's on the display. Just keeps going. There's just one button press. We just keep going until it goes to like nothing. So 37 sine. Oh, what did we forget? What did I forget? We want to be in degree mode. So we need to look for, right now I am in degree mode, but if I see this button down here, rad. Mine says rad, yours might say deg. So right now my calculator is in radian mode. So if I do 37, the calculator's like, oh, 37 radians, that's pretty weird, but all right. It doesn't know that 37 is like more likely degrees and not radians. So if you got negative 0.6435, take a look down, look for a button that says deg for degrees and switch over to degree mode and then go 37 sine, and then it should be 0.6013. Did that work? I don't know what it looks like on Samsung phone because I don't have one. There's a little button that says rad or dead. Do they have a Samsung phone? Oh, that's right. Classroom mob rules. I must say that. Who here knows what 2 plus 3 is? I ain't talking. Don't get nothing out of me. So I just want you to be able to fit 37 and sine. So it feels a little bit backwards, But understand that on your phone calculator, the sign button says, I'm going to take the sign of whatever's on the screen. So phone style. We're going to type 37 and then press the sign button. We don't even have to press enter or equals, but we do have to make sure that we are in degree mode. And that applies to both sides. Okay. This is kind of awesome because if we get to use our phones as our calculators, that means we'll have our phones like during tests and stuff like that. So that means we technically have all the internet. Which is fine. There are ways around that. If I need to know stuff, if I need to know that you know stuff, there are ways of asking. And if you're just going to go on the internet and figure everything out, why are you here? This is so expensive. This is like the cheapest of options, and it's still so expensive. You know what I mean? Yeah. So let's make some calculations. So let's find the cosine of 37 degrees. Round to the nearest 10,000, so 4 decimal places. And let's find the tangent of 37 degrees. Is everybody able to get for cosine of 37 degrees? 0.7986. All good? And for tangent of 37, was everybody able to get 0.7356? So in this case, we could round it to 7356. If you just truncated to 7355, that's also acceptable. So this has been rounded to the nearest 10,000. So this is rounded to the nearest 10,000. And that means 4 decimal places, or 4 places to the right of the decimal point. So sometimes I'll call this 4 decimal places. This is not great terminology for this because it's 4 decimal places to the right of the decimal point, and we leave off that part and just say 4 decimal places, mostly because lazy. The other value I would accept is 7535. This answer has just been truncated. If you just stop writing after 4 decimal places, then this would be truncated to the nearest truncated. We don't want to say the nearest because the nearest 10,000 is the 6. But if you just truncate your answers, I usually find those acceptable as well. So if the instruction said round your answer to the nearest 10,000, I would just I take both as acceptable. Mostly because I usually ask for the answers that go far beyond what's reasonable. What I mean by reasonable is at a certain point, decimal places stop meaning something. So if I wanted to state my weight in pounds, I would say 230 pounds or 231 pounds. It would make no sense at all for me to say my weight is 231.7535 pounds. That's ridiculous because our weight fluctuates way more than that 10,000. Furthermore, now that's changed. Let's pull my keys down and that changes, right? That's what we're measuring way down here, and that doesn't matter. Depending on water versus salt intake, even at a constant caloric intake, your weight will fluctuate up and down all the time. So it's unreasonable to go too far into the decimal places. Despite that your calculator on your phone is like, oh, I've got so many decimal places. That's not better. That's just too far. It's worse. If you just write all these down, that's too much. Stop being so extra, phone. Like if a camera has more megapixels, that doesn't make it better. If the camera doesn't know what to do with the color at this point, then it doesn't matter how many megapixels it has. Does that make sense? Okay. All right. Let's take a quick break. Then we'll come back and learn how to use our calculator to figure out what the angle is.